Welcome to this SAT Math session provided by Tutorgram.
Let's discuss functions. If I plug in x as input inside a function, I will get an output y. Or I can say x comma y is an input-output pair. This means that if I give some inputs into a function, it will give me some outputs. For example, I can write some inputs and their corresponding outputs and try to plot them on a graph. On the x-axis, I will have inputs, and on the y-axis, I will have some outputs. When I plot these data points, I get some straight lines, which represents the function or the relationship between these inputs and outputs. Let's talk about nested functions. Sometimes in SAT exam, they embed one function inside another. Let's say fx is equal to x squared plus 1. We can plug certain inputs and find what this function looks like. This looks like an upward opening parabola. Now, output of function fx can be used as input inside another function gx, which is 2fx plus 3. I can use certain values of x and find the corresponding values of fx and plug them into my function gx. I can plug x as 1, 2, and 5 and find the values of fx and thereafter the values of gx as 5, 7, and 13. Now I can graph a relationship between fx and gx by plotting these data points. On the x-axis, I will have my function fx. On the y-axis, I will have my function gx. As you can see, it is a straight line. In a nested function, output of one function is taken as input into another function. Let's talk about graphical transformations or technique of shifting a graph or manipulating a graph. For example, I'm given a graph of fx equal to x squared. If I want to right shift this graph, I need to subtract that number from x itself. For example, I want to shift my graph to the right side by 1 unit. Therefore, I have subtracted 1 from x itself. My function will be now x minus 1 complete square. On the other hand, if I want to left shift my graph, I need to add that number to x itself. For example, here I want to shift my graph by 1 unit to the left side. Therefore, I have added 1 to the x itself, and my function became x plus 1 complete square. If I want to cause an upward shift of 1 unit, then I need to add 1 to the entire function and not just to x itself. And my function will become x squared plus 1. Similarly, to cause a downward shift of 1 unit, we need to subtract 1 from the entire function. My function will look like x squared minus 1. If I want to vertically stretch my graph by a certain factor, I need to multiply the entire function by that coefficient. For example, I want to amplify all my outputs by a factor of 2. Therefore, I multiplied the entire function by 2 on the outside, and it became 2x squared. On the other hand, to cause a horizontal stretch or stretch along the x-axis, I need to divide the entire function by a certain coefficient. For example, here I divided my entire function by 2 and my graph got stretched horizontally by a factor of 2. If we want to reflect our graph across x-axis, then we need to apply negative sign to the entire function. Our function therefore will become negative x squared, and we will get a mirror image across the x-axis. If we want to reflect our graph across y-axis, then we need to replace x with negative x, and our function will look like negative x cubed, and we will get a mirror image across the y-axis.
I would like to tell you about our services at Tutorgram. We provide one on one sessions to both high school and college students in physics, chemistry, math, and biology. We also help students increase their score in SAT, GRE, GMAT, and MCAT. All our tutors are graduates of Ivy League universities, and they will be more than happy to create personal and interactive study sessions for you. If you are interested in a trial lesson, please email or call us with your specific requirements, and we will get back to you.
Let's apply these concepts to a problem. They have provided me some data of x and g of x. There's another function f of x, which is absolute value of gx. F of 7 is equal to t, and they want me to find the value of f of t. I know that fx is absolute value of g of x. Therefore, I can easily find f of 7 as absolute value of g of 7. I can get g of 7 from the table as negative 3, apply the absolute value function, and get the output as positive 3. Once I know that t is 3, I can easily plug that into my function f. They want me to find f of t, or f of 3, which will be equal to absolute value of g of 3. I can get the value of g of 3 from the table as 15. Therefore, my final answer will be 15. In this problem, they gave me a function f of x minus 1 equal to x plus 1, and they want me to find the value of f of x plus 1. To get x plus 1 inside the parentheses, I can plug x plus 2 in place of x. The moment I do that, on the right side, I will get x plus 2 plus 1, or x plus 3. Therefore, f of x plus 1 is equal to x plus 3. This problem involved manipulating x minus 1 to look like x plus 1. In this problem, I'm given some data about x, f of x, and g of x, where k and m are unknown. I'm given that f of 4 is equal to m plus 9, and g of 4 is equal to 2k minus 4. They want me to find the value of f of 3 plus g of 1. To solve this problem, first I need to find what m is and what k is. I can easily find m by using value of f of 4 as negative 29. M plus 9 will be equal to negative 29, and therefore m will be equal to negative 38. Similarly, we can find the value of k by using g of 4 as 88. 2k minus 4 will be equal to 88, therefore 2k will be equal to 92, or k will be equal to 46. Now to find the value of f of 3 plus g of 1, all I need to do is add k and m. It will be 46 minus 38, or 8. Here I'm given a graph and I'm asked a bunch of questions based on the features of this graph. What is the y-intercept of fx? Y-intercept is where the graph crosses the y-axis. As you can see, this graph crosses the y-axis at the origin, therefore y-intercept will be 0, 0. In part B, they want us to find the greatest value of fx, that is the highest point of the graph, or it happens at x equal to 3. In the next question, f of 4 is equal to a. They want us to find a and thereafter find what f of a equal to. F of 4 is equal to negative 3. Therefore, a must be negative 3. F of a, or f of negative 3, can be easily found from the graph as positive 5. Therefore, final answer is positive 5. In the next problem, f of negative 2 is equal to b. They want us to find f of b. Value of f of negative 2 can be easily found from the graph. It is negative 2. Therefore, b is negative 2. F of b, or f of negative 2, can again be found from the graph as negative 2. In the next problem, f of negative 1 is equal to e. We can look up the value of f of negative 1 as positive 4 from the graph. Therefore, e is equal to positive 4. We can find f of 4 minus 6 by using the graph. F of 4 is equal to negative 3. We can plug negative 3, subtract 6, and we will get negative 9. In the next problem, f of 1 is equal to g. We can look up the value of f of 1 from the graph as negative 6. Therefore, g is equal to negative 6. F of negative g will be f of negative 6 or f of positive 6, which we can easily find from the graph. It will be equal to negative 4. Therefore, f of 6 is equal to negative 4. In the next problem, f of 5 is equal to c. We can look up the value of f of 5 as negative 5 from the graph. Therefore, c is equal to negative 5. F of c plus 1 can be written as f of negative 5 plus 1 or f of negative 4. The value of f of negative 4 can be found from the graph as positive 3. Therefore, final answer is positive 3.
If you're looking for one-on-one tutoring, please feel free to reach out via email or cell phone, and I will be happy to answer any of your questions. Please subscribe to our channel for more SAT content. Feel free to share this video with any friends who might need help with SAT math.